Assalamualaikum warahmatullahi wabarakatuh and welcome. So my name is Muhamad Akmal bin Ridzuan and my matric ID is AA190023. So for experiment number 8, which is for subject BAB 30401, Power Engineering Laboratory 1, for experiment number 8, which is the open and closed loop for the speed control system. So I perform the simulation for activity 1, which is the open loop speed control system. So the objective is to observe the input voltage and the tachometer voltage for the different motor speed. So using the MATLAB simulate, we must construct the block diagram of an open loop speed control system as in figure 8.4 by using the MATLAB simulate. So I have prepared the diagram. So as you can see, this is the input, the electrical part, mechanical part, and the tachometer constant. Okay, next we must set up the parameter value for the open loop speed control system, and then we must set the input voltage to 240 volt, back to 0, and simulation time to 10 seconds. Okay, so we set up this into 240 volt first. Okay, 240 volts, 0, and then break this is equal to 0, and then we must, so we can run the simulation. Okay, now we must observe the waveform for the input voltage first. So as you can see, this is the input voltage waveform, which is a straight line. Okay, this is the torque, the waveform for the motor torque. Then for the motor speed, as you can see, this is the waveform for the motor speed, and then this is the waveform for the tachometer voltage. Okay, for the next part of the activity 1, given the block diagram set, we want to figure out what is the input voltage and the tachometer voltage when the motor spin is of the motor is given. So as you can see, this is the block diagram in MATLAB Simulink for the open loop speed control system to figure out the input voltage and the tachometer voltage. So this is the circuit I have created in the MATLAB Simulink. So first we take a look at the what is the input voltage and the tachometer voltage when the motor speed is 400 rpm. Okay, so we put the input is equal to 400 first. 400. So basically it's the same as the first part, except in this part we have the tachometer constant before the electrical part, and the input is the speed, not the voltage. Okay, so we run the simulation. We wait for a while. So as the input speed is 400 rpm, you can see that the input voltage is equal to 36 voltage, while the tachometer is 26.02. So I have learned the calculation for the other, for the input voltage and the tachometer voltage when the motor speed is 800 and so on. So this is the value for the input voltage and the tachometer voltage, while this is the graph for the motor speed against the input voltage, and this is the graph for the motor speed against the tachometer voltage. Let me change the title first. Against the voltage. Okay, so I think that's all for the activity 1. So that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Hello, hi, Assalamualaikum. My name is Muhamad Fathurrahman bin Rustam. My number is DE190162. I will explain about the activity 2 for this lab. Okay, firstly, we need to repeat the step 4 in activity 1, which is we need to set the input speed for 2500 rpm, and then we need to record the input voltage. Okay, so now we go to the simulation. Okay, here we set the input speed at the final value, which is the 2500, and then we click the run Okay, so the circuit is we use from the activity 1. Okay, so now, okay, we record. So the result is 162.5 volt for the input voltage. So we use this input for the next step. Okay, so next is we need to repeat the step 1 in activity 1 by using the input voltage from the step 1. Okay, so now we need to set the break scale, adjust the break scale from 0, 3, 6, 9, 12, 15, 18, and 21. And then we record the motor speed in RPM. So now we go to the circuit. Okay, so this circuit for activity 2. Okay, so now input voltage, we set the 162.5 from the latest the input voltage. Okay, so now we click to run. Yep. So we need to set from 0 for the break scale, and then okay, we see the motor speed. Okay, so now we can see the motor speed is 2049 RPM. Okay, here at this point for 10 seconds. So we adjust again to 3, fly, and then we click run. Okay, you can see 2265 RPM, and we adjust again to the 6 value. Click run. Okay, we record the data for the 2034 RPM. So next is 9 for the next value break scale of break scale. Click run, and the motor speed. Okay, 1803. 1803. And then next 12. 12. Okay, the motor speed 1572 RPM. 16. 1264. Okay, all this will be recorded in the table versus the break scale. 15, 18. 18. 1110. Okay. Lastly, for the 21 for the break scale, the input voltage is still same, 162.5. Lastly is 790. 879. Okay, so that's all from me. So next we will need to plot the graph for the speed versus against the break scale. Okay, that's all from me. Thank you.
Okay, Assalamualaikum. My name is Muhamad Haiqal Najmi, metric number DE200100. Okay, so for the activity 3, closed loop speed control system. Okay, so that's construct for the figure 8.6 block diagram for closed loop speed control system. Okay, so the question is for the parameter proportional gain P is 200 and the saturation blocks upper limit we need to put it into 4 volt and the saturation block lower limit 0 volt. Okay, so for the question, okay, so we need to have this and then the input voltage we need to put it like the activity 3 here. And for the break scale, okay, so let me see the simulating. Okay, so I've done the simulating here. Okay, so we have this input voltage, okay, this sum, proportional gain, okay, saturation, okay, sum, and the electric part. Okay, so this equation, okay, and sum again, and the mechanical part, and this, okay, we put it 0 on the break, and for the torque constant we put it 0.05, and for the tachometer constant we put it 0.065, and this is for speed output. Okay, so what we need to do here, okay, just click to the input voltage. Okay, put the initial value 162.5. okay, like usual, and this is same initial value and final value same. And for the sample time we put it to 10. Okay, alright, so for the proportional gain you can just put it 200. Okay, so for the saturation upper limit, okay, like the equation, we put it to 240 and the lower limit is 0. Okay, alright, so for the break, okay, first we need to put it to 0 first. Okay, so let me see the graph. Okay, so just run the simulation. Okay, and then you can see the graph. Okay, so this is the graph 0 to 2500. Okay, here. Okay, so this is for graph here, and for the value, okay, we need to put display. Okay, so this is display, just put it out. Okay, to find the value like the question. Okay, break scale, okay, we start with 0 first. Okay, so okay, just put it here. Okay, and then just run the simulation. Okay, first we will get 2488. Okay, for the 0 break, 0 scale for break. Okay, so then for the break scale put it 3. Okay, so here we need to change the break to the value of break to 3. Okay, and then run the simulation back, and then we will get the answer is 2489 and 86. Okay, so then put it to 6. Okay, and then run the simulation, and then we get the answer is 2485. Okay, so then you will change the value, follow this break scale voltage here, and then we get the motor speed RPM on the display here. Okay, so that's all for the activity 3.